Whether you're baking cookies, manufacturing microchips, or even just processing invoices, consistency is absolutely king. But how do you really know if your process is stable and consistent day in and day out? Well, that's exactly where statistical process control comes in. It's an incredibly powerful tool designed to give you a clear, data-driven answer to that exact question. I mean, think about it for a second. Every single process out there has some level of variation. Your commute to work, it's never exactly the same time down to the second, right? The coffee you make in the morning has subtle differences. And in business, that little bit of variation can be a huge deal. It can lead to defects, waste, and ultimately unhappy customers. So the real question isn't whether variation exists, it always does, but whether it's actually under control. So here's what we're going to do. First, we'll talk about what true consistency really looks like. Then, we'll learn how to decode the noise that exists in every process. After that, we'll introduce the star of the show, the control chart, and learn how to read its signals, pick the right one for the job, and finally, see the massive advantage all of this gives you. All right, let's dive right into our first section, the quest for consistency. The whole idea here is to shift from a reactive mode to a proactive one. It's all about getting out of that constant firefighting and into a state where things are predictable and under control. So, what exactly is statistical process control, or SPC for short? Well, at its heart, it's a data-driven method, and it's a huge part of quality frameworks like Six Sigma. And here's the real game changer. Instead of just waiting until the end to inspect a product for defects, SPC is all about monitoring the process itself in real time to prevent those defects from ever even happening. Okay, so picture this. You and your team just spent months on a huge project to improve a process. You cut costs, you sped up delivery time. Fantastic! But the big question is, how do you make it stick? How do you make sure that 6 months from now, things haven't just slid back to the old, inefficient way? Well, that's the control phase of any improvement project. SPC gives you the tools to lock in those hard-earned gains and make sure they last. Now, we're at what I think is the most crucial concept in this entire topic. This is the big aha moment. To really get the most out of SPC, you have to understand a fundamental truth. Not all process variation is created equal. So let's decode it. Every single process has two kinds of variation, or noise. On one side, you've got common cause variation. Think of this as the normal, low-level background noise, the statistical hum of a process that's stable. On the other side, you've got special cause variation. These are the surprises, the outliers, the loud bangs that signal something unusual has just happened. Let's make that a little more real. Common cause variations are those small, unavoidable little fluctuations you just expect. Things like tiny differences in raw materials, minor machine vibrations that are just part of its normal operation, or subtle differences in how two highly skilled people do the same task. You're never going to get rid of this noise completely, but you can understand it and manage it. Special causes, though, they are a totally different animal. These are the red flags. A machine suddenly breaks down. A brand new, untrained operator is put on the line without proper guidance. Your supplier sends you a batch of raw material that is way, way off. See, these things aren't part of the normal hum of the process. They're alarm bells, and they demand that you stop and investigate right away. So, that's the big question, right? How in the world do you tell the difference between the everyday background noise and a real, full-blown alarm bell? Well, that brings us to the hero of our story. Let's talk about how to actually listen to the voice of the process by using a tool called the control chart. A control chart is actually beautifully simple. It's really just a graph that plots your data over time. You take measurements from your process at regular intervals, maybe the weight of a product every hour, and you plot each point in the order you took it. It's this visual timeline, this story, that lets you spot patterns, shifts, and trends that you'd otherwise miss. Building a basic one is pretty straightforward. It's just 3 key steps. First, obviously, you plot your data over time. Second, you calculate the average of all that data, and that becomes your center line right down the middle. And third, and this is where the magic happens, you use some simple statistics to calculate an upper control limit, or UCL, and a lower control limit, or LCO. And this quote, it just nails a super important point. Your control limits, the UCL and LCL, they are calculated from your process data. They represent the natural, expected range of variation. They are literally the voice of your process telling you what it's capable of. This is completely different from specification limits, which are what the customer wants. And you could have a process that is perfectly stable and in control, but still making products that don't meet customer specs. They are two very different things. I love this analogy. Think of it like you're driving down the highway. The center line of the chart is the middle of your lane. The upper and lower control limits, those are the white lines on either side of the road. As long as you're driving between those lines, you're in control. That normal, tiny bit of weaving you do to stay centered, that's just your common cause variation. But what happens if you swerve over the line and hit the shoulder? Yep, that's a special cause event.
Okay, so we've got our chart, we've got our highway analogy. Now let's get down to business. How do you actually read the signals and figure out what the chart is trying to tell you?
Honestly, reading a control chart boils down to one simple question. Is my process stable or not? If all your data points are just kind of bouncing around randomly between those control limits, you're good. Your process is in control. It's stable, it's predictable. But the second you see one of a few specific signals, ding, 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 the chart is yelling at you that it's out of control, and a special cause has snuck in that needs your attention. So what signals are we looking for? Well, the most obvious one is a point that actually falls outside the upper or lower control limits. That's your car on the shoulder of the road, a big red flag. But there are sneakier ones too. For instance, if you see a run of 7 or more points in a row all on one side of the center line, that suggests the whole process average has shifted. Or a trend of 7 or more points all climbing up or falling down tells you something is gradually changing. These are your crucial early warning signals. All right, just a quick heads up here. A control chart isn't a one-size-fits-all tool. You've got to match the specific type of chart to the kind of data you're collecting. Let's just take a quick glance at the 2 most common ones you'll run into. Look, we're not going to get bogged down in a deep statistics lesson. The main thing to remember is that the chart you pick really depends on your data. For example, if you're pulling, say, 5 samples off the line every hour and averaging them, you'd use a different chart than if you were just tracking one single temperature reading each day. The big takeaway is simply this: there's a right tool for every job. Okay, so we've defined the problem, we've learned about the tool, and we know how to read the signals. So let's bring it all home. Why does any of this actually matter? What's the real data-driven advantage? Oh, the benefits are huge. You start catching problems before they turn into thousands of defective products. That directly translates to less waste, less scrap, and less rework. You stop making decisions based on gut feelings and start using cold, hard data. And, like we said at the very beginning, this is the key to making your improvements last for the long haul. And all of that adds up to better quality and way happier customers. So here's the bottom line. Every single one of your processes is talking to you, all the time. It's constantly generating data. And that data is telling a story. By using tools like control charts, you're finally learning how to speak its language. When you give your process a voice, you can finally hear what it's saying. The real question is, are you listening? What is your process trying to tell you?
Thank you for watching. If this video helped you understand that, please give it a like, thumbs up, subscribe to the channel, and be sure to turn on the bell so you never miss our next Six Sigma lesson. We'll see you in the next one.